So for this lecture, we will discuss hypothesis testing. So first, we need to have a definition of a hypothesis test. So a hypothesis test is a process that uses sample statistic to test a claim about the value of a population parameter. So in hypothesis testing, we have two basic hypotheses that we need to consider. So the first one, we have the so-called the null hypothesis, so denoted by H naught. So the null hypothesis is a statistical hypothesis that contains a statement of equality. And the second one, we have the alternative hypothesis, denoted HA. So the alternative hypothesis is the complement of the null hypothesis. So it is a statement that must be true if HO is false and it contains a statement of strict inequality. In stating hypotheses, we have some types of errors that we need to consider. So we have a type 1 and a type 2 error. So a type 1 error, it occurs if the null hypothesis is rejected when it is true, and a type 2 error occurs if the null hypothesis is not rejected when it is false. And then we also have the so-called the level of significance, denoted by alpha. So the level of significance is the maximum allowable probability of making a type 1 error. Okay, so here are the steps in constructing a hypothesis testing. So the first thing we need to do is to state HO and HA. But before this, we need to first find the claim in the problem. So the second step is to state the level of significance. So basically, the value of alpha is usually 0.05 or 0.01. So depending on the problem given. For number 3, so determine the statistical test. So for the statistical test, so there are some conditions that we need to consider for us to use different kinds of statistical test. Then for number 4, for decision, so for the decision, we have two main decisions that we have. So the first one is to reject HO, and the second one, failed to reject HO. So notice that we are focusing at HO, not in HA, in making decision. And then lastly, for the conclusion, so the conclusion, you state a simple argument regarding on the evidence that you made in your analysis. So let us take this example. So in auto racing, a pit stop is where a racing vehicle stops for new tires, fuel repairs, and other mechanical adjustments. The efficiency of a pit crew that makes these adjustments can affect the outcome of a race. A pit crew claims that its mean pit stop time for 4 new tires and fuel is less than 13 seconds. A random sample of 32 pit stop times has a sample mean of 12.9 seconds. Assume the population standard deviation is 0.19 second. Is there enough evidence to support the claim at alpha equal to 0.01. So for this example, we will use a statistical software called Megastat for us to have a convenient way to interpret the given. So to do that, we first write mean, SD, and N. So mean for the mean of the samples, SD for the standard deviation of the sample, and small n for the number of samples. So in the example, we have a random sample of 32 pit stop times. So we have 32. The sample mean was 12.9. And then for the standard deviation, that is 0.19. So 0.19. Now, we can now analyze the given problem using Megastat. So we click Megastat, hypothesis tests, and then mean versus hypothesized value. So this dialog box will appear, and then we click this input range. We drag our observations here, values, and then for the hypothesized mean in our problem, so a pit crew claims that its mean pit stop time for 4 new tires and fuel is less than 13 seconds. So I already have here a sheet wherein I can write the steps in hypothesis testing. So we can write the claim here. So the claim was, so the mean time, let's say mean time is less than 13 seconds. Now, observe that our claim has an inequality symbol, or may I say it is a strictly inequality symbol. So for that, this claim will be put it in the alternative hypothesis. So we may write in our HA, mean time is less than 13 seconds. Now, what will be our HO? We know that HA is the complement of HO. So vice versa, we may say that HO is the complement of HA. So we may type in, or we may write, mean time is greater than or equal to 13 seconds. Okay, so observe that our HO has an equality statement. Okay, so moving on, our level of significance in the problem was 0.01. for our statistical test. So for this at this moment, you have to just accept the statistical test that I will use. So for this statistical test, I'll write here Z test. Now, for the p-value, we will use megastat. So the hypothesized mean here, that would be 13. And then for the alternative, we have less than. Then for this section, we click Z test. And for the confidence interval, since we have a 0.01 level of significance, so 1 minus the value would be 0.99 or 99%. So we will choose 99%. So we may uncheck this display, so we will not use that for this lecture. And then we may click OK. So this dialog box will appear, so you click yes, and then after that, so this will be the result. So notice the color here. So take note, if this value has a color, it means that you need to reject the null hypothesis, or basically, if the p-value is less than to the designated alpha, so that means you have to reject the null hypothesis. So since this value has a color, so we need to reject HO. So we will type so we will first write the p-value, which is 0.0015, and then for the decision, we have reject HO. Now, for the conclusion, we will refer it to the claim. So our claim was the mean time is less than 13 seconds. Now, our claim is at the alternative hypothesis. So our decision is reject HO. So we are in favor in the alternative hypothesis. So we may write here, there is a sufficient evidence to support the claim.